yell a lot. All right, number 21. Find two complex number roots for the equation. Here we go, boys. Cole, ready? Okay, here we go. Find two complex number roots for the equation x squared minus 4x plus 21 equals 0. What does the word complex mean? Nope. Complicated, yes. So that means that it's not just going to be, the answer is not just going to be like 5 or 2 or 0 or something. So we're going to have to use the quadratic formula to figure these out. Good news, quadratic formula right there on the wall in front of Shelby and Addison. Okay, so if you can't remember it and for some reason you don't have it written down in your notes, there it is. Bless you. So opposite of b is 4 plus or minus the square root of b squared. Don't be confused. That will always be positive even if b is negative, because when you square a negative number, you get a positive number. Minus 4 times 1 times 21 all over 2. Anything weird going on there yet? You guys could all do this on your own? Yeah? All right. Here's where the excitement happens. 4 times 1 times 21 is 84. So if I go 16 minus 84, I get a negative number. What do I get? Negative 68. Okay. Okay, but that's okay because it said complex, and you guys said complex means complicated, and you're right, it's complicated because it does involve an imaginary number. But let's simplify this a little bit first. What's the highest number you know the square root of that goes into 68 evenly? I don't know the square root of 68, and it doesn't go into 68 evenly, but nice try. Give me another one. 64 does not go into 68 evenly, but we're halfway there because at least I do know the square root of 64. It needs to be two things, a number that I know the square root of, like 4 or 9 or 16, and it has to go into 68 evenly. 4. Okay, so that means that I can rewrite the square root of negative 68 as the square root of negative 4 times 17. Okay, thank you. Divided by 2. Okay, what is the square root of negative 4? 2i. Yeah, good. The square root of 4 is 2 because it's negative. So if you're going to square root a negative number, you're going to have an I in there. All right, and then hey, fun thing, all of these numbers are divisible by 2. So let's go ahead and do that. 4 divided by 2 is 2. 2i divided by 2 is I. I'm not going to divide the square root of 17 by 2 because it's inside the square root. And then this divided by 1 is just 1, which I don't need to put on the bottom anymore. Okay? Is that a complicated enough answer for you? Okay. Nope, that's it. It did say find 2 of them. Bless you. Did we find 2 of them? Yes. One of them is 2 plus I root 17, and the other one is 2 minus I root 17. Can I go on? Okay. Okay, next one. Find a polynomial of degree 3 with real number coefficients that has 3 plus I and negative 7 as zeros. All right. So immediately what you should think of when you see this is you should say to yourself, if 3 plus I is a 0, what's another 0? 3 minus I, good, because that represents a square root, and so when you're solving an equation, you'll always have a plus and a minus, okay? So not only are 3 plus I and negative 7 zeros, 3 plus I, 3 minus I, and negative 7 are all together. Okay, so then how do you turn that into a polynomial? Yeah, parentheses x minus 3 plus I times x minus 3 minus I times x minus negative 7. Okay? Yeah, tomorrow and Friday. What? What? Tomorrow and Friday. It's going to be a 2-day. Will? Okay, cool beans. And guess what? You're done. Okay? I told you when we went through these that I would not make you do them when there are three things in the parentheses, because this is a nightmare. Okay? And then you have to FOIL them out. I hope not. You could, if you wanted to, you could clean this up a little bit by getting rid of some parentheses and distributing the negatives. That's a little bit cleaner, but you don't have to. Glory? You always subtract the zeros because, yeah, it's always minus, yeah. All right, number 23, the graph of y equals 2 minus a to the x plus 3 is best represented by which graph? So when you look at y equals 2 minus a to the x plus 3, you say to yourself, the 2 moves the graph up 2. The negative does what to the graph? Flips it. Yep, flips over x-axis. And the plus 3, awesome, you guys are the best. The plus 3 moves the graph to the left 3. So, because the 2 in the front. No, that would be if it was times. But there's a minus sign in there, which means it's not times. Okay? All right, so you would be starting with the graph that would look like this, and then you want to flip it upside down, move it to the left 3, and move it up 2. So which one is that? A? Okay, yeah, I'll take that. Looks like it's flipped upside down. Oh no, that looks... hang on. A has to be bigger than 1, yeah. So that means it's exponential growth. Okay, so if I take this and I move it up 2, it would look like this, right? And then I flip it over the x-axis, so then it would look like this. And then I move it to the left 3, so then it would look like this. Not really, though. Did I do those in the wrong order? E, none of the above. Maybe we have to do the flip first, like order of operations. You have to do the multiplication thingy first. Okay, so let's flip it over the x-axis first. And then let's move it to the left 3. So that would move it over here. And then if I move it up 2, then it looks like this. So then that looks kind of like C, but yeah. Yeah, that's not great, is it? That wasn't like really great teaching on my part. Like I've not really. Yeah. So maybe if I give you this problem, you just have to say these things in words, what happens to the graph. How does that sound? All right, number 24, describe how the graph of g of x equals 3x plus 2 over x minus 4 can be transformed or can be obtained by transforming the graph of y equals 1 over x. All right, to do this, you're not going to like this very much, but don't hate the player, hate the game. I need to go 3x plus 2 divided by x minus 4 to start with. Yeah, so what goes up here? 3. And then if I multiply this back through, I get 3x minus 12. Yeah, we're doing the long division. Then I need to subtract these, so I'm going to change the sign and add. Those two things cancel, and then I get 14. Okay? and that's the remainder. So the way that I can write, it was negative 12, yeah, but remember when you do that next step in long division, you subtract, right? So I went 3x minus 3x, those cancel, and then I went 2 minus negative 12 is really 2 plus 12, so that's where I got the 14. Yeah, I'm not actually skipping any steps. Yeah. Yeah, I just went 3 times, is that the step that you're thinking of, Emma, that I'm skipping? 3 times x minus 4 is 3x minus 12, is that what you're wondering about? Like, okay, so what we just figured out, hang on just a sec, Shelby, is that 3x plus 2 divided by x minus 4 equals 3 plus 14 over x minus 4. Okay? 3 because we got a 3 right here. 14 because that's the remainder. Ben told me. Yeah. All right, so now we can answer the question, what does the 3 do to the graph? Up 3. What does the minus 4 do? To the right 4. And what does the 14 do? Yep, there's your stretch. Stretch of 14. Okay? Uh, 2 minus negative 12. So I'm taking and I'm subtracting this whole thing. Okay? Yeah, so let's talk about vertical and horizontal asymptotes. Normally, 1 over x, I'm sure you guys have this memorized because it's one of the 10 basic functions. Normally 1 over x looks like this with horizontal and vertical asymptotes at 0, right? So if I move it up 3, where is my horizontal asymptote now? Up 3, yeah, so my horizontal asymptote is at y equals 3. Okay, yeah, and then my vertical asymptote, since it got moved to the right 4, is at x equals 4. Okay? Holding. Yep. You can get 4 out of 5 of these answers correct without doing all the work that I did. Here's the up 3. Here's the right 4. Okay? And those tell you the horizontal and vertical asymptote. So the only thing you would get wrong is the stretch of 14. Yeah. No, I'm going to like cut and paste stuff and then retype it so that, well, obviously the numbers will be different, but I'm not going to use this format either. I'll try, but some of it, yeah, I want to try and like clean it up to make it a little bit easier for you guys. Okay. Okay, number 25, easy peasy. Describe the transformations. What does the 4 do? Stretch of 4. Okay, the plus 2 is the left 2. And then the minus 3 is a down 3. All right? Uh-huh. How'd that go for you, Kinsey? Piece of cake? Did you go to El Rancho and take it? Okay. Is it cold outside? Yeah, go like 3 blocks away, just knock on some random door and be like, can I come in and hang out in your living room and I gotta take a test. All right, number 26. The number of elk after t years in a state park is modeled by the function. Part A, what is the initial population of elk? What does t equal at the initial time? What is our initial value of t? No. What are we starting at? No. Then 0. Okay? So when it says what is the initial population of elk, that means plug in 0 for t and see what you get. So negative 0.03 times 0 is what? 0. Because initial means starting. Yeah, like at the beginning of time. Yeah. So your initials are E whatever J because those are the starting letters in your name. So this is the start of time. Yes. Mind blown. I have taught Emma something. Okay. Anyway, so this is 0. E to the 0 is what? 1. 75 times 1 is 75. 1 plus 75 is 76. So to figure out what the population is at time t equals 0, I just need to go 1216 divided by 76. And if I do that, I get 16. So we started out with 16 elk. Well, when I plugged in 0 for t, then that just disappeared because, yeah, 0 time. That's the answer for A, 16 elk. We did this. I remember working with you on this. Okay, when will the number of elk be? 750. So now I'm going to go 750 equals 1216 divided by 1 plus 75e to the negative 0.03t, and I'm going to solve that for t. Yep, exactly right. So I'm going to like basically cross multiply here. What Gloria is saying is I'm going to multiply the bottom times 750, and then I'm going to multiply the top by 1. So 750 times 1 is 750, plus 750 times 75 is, you know, say, oh, yeah, go ahead. 750 times 75. 825? Oh, times. 56,250, thanks Cole, times e to the negative 0.03t, and that equals 1,216. Not anymore, no. Yep, subtract 750. So 56,250 e to the negative 0.03t equals 466. Thank you. Okay, now what? We're going to do a natural log in just a second, yeah. Okay, so now I have to go 466 divided by 56,250. So I'm dividing both sides by 56,250. So that gives me e to the negative 0.03t equals 0.0088. Okay. I did. 0.00828. Multiplied 750 times 75. Grace? 0 point what? 0.18? Well, because I divided both sides by 56,250. From here to here? From here to here? This? Well, I divided both sides by 50. Oh, what do I do next? Oh, natural log both sides to get rid of the e. Okay, so you guys remember natural log and e are inverses of each other. So I'm going to natural log both sides. So over here the natural log and the e cancel. So you get negative 0.03t equals the natural log of, did we get independent confirmation of the 0.00828? There's some dissension. It is correct. Carter said this is what he got to. Okay, 466 divided by 466 divided by 56,250. Yeah, 0.00828. So yeah, I don't know. Okay, so that's equals the natural log 0.00828. What is the natural log of 0.00828? Yeah. What'd you get, Gloria? I'm sorry. Thank you. Negative 4.79. And Cole is so sick and tired of that negative 0.03. Let's get rid of it. Divide. Yeah, this is a tough one for sure. 159.8. So can I go 160? Are you guys okay with that? Yep. So 160 years. So don't hold your breath. It's going to take a while. Okay. Holding on. That's a tough one. Okay, C is super easy. A and C, both really easy. B obviously is a little bit of a challenge. But Ben, what is the answer to C? 1,216. The number on the top is going to be the horizontal asymptote of the graph, so that's the highest that the population will ever get. It's called the limit to growth. And thin out the L curve. You ever go up to White Pass and go skiing? No. It's always a little bit scary to come down because the elk gets later in the day and the elk, and you drive through like a herd of elk and they're big and they're really close to the road. Uh-huh. Yeah. Huh. Yeah, yeah. It's a little Indian family. There's like 3 of them. Yeah. All right, number 7. Arturo invests $2,700 in a savings account that pays 9% interest compounded quarterly. So the equation for his moolah is going to be the $2,700 that you start with, times 1 plus, remember you need the 1 to hold the place of the original investment. What is 9% as a decimal? Okay, but we are only getting that quarterly, so we're only getting, we're getting that a fourth each year. Huh? Okay. But because we're getting it quarterly, we're getting it 4 times per year. And we need to figure out when that's going to equal 4,550. Yeah. Okay. You guys see where the formula comes from? All the pieces? The money, the interest rate, the 4, okay? Well, 2 4s, I guess. So how do I solve that for t? Divide by 2700. One more. Okay, so 1.685. All right, now we have our variable in the exponent. How do we solve that problem? Right, what math function allows me to bring the x, right, natural log or log? Which one do you want to do, natural log or log? Okay, natural log has fewer letters, so let's do that. So I'm going to natural log both sides. The reason that I did that is because of exactly what Tristan said. Now when I natural log both sides, that means I can take this exponent and put it down in front. So that is 4t natural log of 1 plus 0.09 divided by 4 equals what is the natural log of 1.685. Okay? 0.522. Okay, how about while we're at it, let's figure out the natural log of 1 plus 0.09 divided by 4. What is all of this stuff equal? Just do that on the calculator. .0222. All right. So now how do we solve that for t? Divide by 4. Okay. So if I divide by 4, then I'm left with t times 0.0222 over here equals, what's 0.522 divided? 0.1305. And then my last step is to divide by 0.00222. And when you do that, you get so it's going to take Arturo a lot less time to get $4,550 than it is for us to get 175 elk. Woo! Yeah, those are rough, huh? Well, good thing those won't be on here till Friday because they're the second half of the test, so you got an extra. Yeah, I don't think you guys can do 30 of these in a day, in an hour. Yeah. Uh-huh. Yeah. Oh, you know what? Can you copy from Corey? Because I know you stepped out. Oh, okay. Your theme should be what? Okay. Oh. Did you guys, uh-huh. Uh-huh. Right. Right. Um, oh, so you still have to vote? Okay, anyway, so math. 28, evaluate all 6 trig functions. So we got to find the, whoa, Glory. Almost there, running out of time. What's the missing side there? What's 17 squared minus 8 squared? 15? Okay, so then if I need to find all 6 trig functions, you guys just did this on your test last week, right? So we're using this angle right here. So the sine of theta is opposite 15/17. Oh, don't jump ahead to tangent. Let's not forget our old friend cosine. Oh, it is? Oh, okay. So tangent is opposite over adjacent, which is 15 over 8. And then you guys hopefully remember that cosecant goes with sine. So that'll be 17 over 15. Really though, for your prom theme, America. Oh, okay. Yeah. What about, isn't it supposed to be like moonlight in Miami or something? It's supposed to be something like romantic and... Uh, oh, yeah, because that's like Hollywood. Urgh. Oh, good. All right, nice job. Yeah. Are we good now? We gotta go. What's up with 31? Oh, okay. So we hang on. We can do 29 and 30 real quick tomorrow. 31 and 32 are from chapter 5, which we have not gotten to yet. So you would not know how to do those, so we're not. Okay. Yes. I mean, I won't be here, so. Not doing 31 or 32. I think.